Chapter 3, Section 4, Parallel and Perpendicular Lines. So to start this off, we're going to begin with a few theorems. Theorem 3.8 says that if two lines are parallel to the same line, then they're parallel to each other. So this is similar to the transitive property, but we're going to explain it as a theorem if we're given it in a proof. So if A is parallel to B and B is parallel to C, then A is parallel to C. In a proof, we would write, if these were our givens, this would be our statement, and our reason would be this. If two lines are parallel to the same line, then they are parallel to each other. Theorem 3.9 states that in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. So in other words, M is perpendicular to T, and N is perpendicular to T. These you could think of as corresponding angles. If corresponding angles are congruent, then the lines are parallel. So M is parallel to N. Now you can see a proof of this here. So we have a slightly different picture. R and S are both perpendicular to T. That's given. We want to prove that R is parallel to S, obviously not using this theorem. So, like I said before, angle 1 and angle 2 are right angles by the definition of perpendicular. So you would say perpendicular lines form right angles. So just fix this little bit from the textbook. Angle 1 and angle 2 are right angles. If you're writing it as a statement and reason, your statement would be angle 1 and angle 2 are right angles. Your reason would be that perpendicular lines form right angles. Then your statement would be angle 1 is congruent to angle 2 because corresponding angles are congruent, which means that R is parallel to S. So you'd have first your given. If you did it in a statement reason, a two-column proof, this is a paragraph proof, you would have your given statements. Then you would state that angle 1 and angle 2 are right angles because perpendicular lines form right angles. Then you would say that angle 1 is congruent to angle 2 because all right angles are congruent. You could say something about right angles measure 90 degrees. Since both angles have equal measures, they are congruent, something along those lines. And then your final statement would just be to say R is parallel to S, and your reason would be if corresponding angles are congruent, the lines are parallel. And that would be the end. Same thing written as a paragraph proof, just never write the definition of perpendicular, actually write out the reason. Our next theorem states that in a plane, if a line is perpendicular to one of two lines, of two parallel lines, then it's also perpendicular to the other. So if we know that L is parallel to M, and we know that this is a right angle, since the lines are parallel, corresponding angles are congruent, so that would also have to be a right angle, which means N would also have to be perpendicular to M. Now, in the perpendicular transversal theorem, which is what we see here, lines must be in a plane. So the diagram at the right shows why. In the rectangular solid, AC and BD are parallel. EC is perpendicular to AC, but it's not perpendicular to BD. EC and BD are skew because they're not in the same plane. So this only works, underline it, make a note of it, if they're in the same plane. Because we can see that AC and BD are parallel. CE is perpendicular to AC, but it's actually skew to BD because they're not all in the same plane.